Welcome to Math Zone African Motives. Today, we're diving into the world of parabolas. In this tutorial, you will learn to understand the key features of a parabola, master the 6 essential steps for sketching a parabola, and practice identifying these features from a given equation. Our main goals are to define what a parabola is, break down the process of sketching it step by step, and understand how to describe a specific parabola using its important features. Let's start with the basics. What is a parabola? In the language of mathematics, a parabola is defined by a specific equation. The general form of the graph of a parabola is y equals ax squared plus bx plus c. This form, y equals ax squared plus bx plus c, is crucial, so take a moment to commit it to memory. This equation creates a characteristic U-shaped curve. This curve can open either upwards or downwards, depending on the value of a. As you can see, we have two types of parabolas. The one on the left opens upwards when the value of a is positive. The one on the right opens downwards when the value of a is negative. Now, let's look at the important features that apply to all parabolas in this form. First, the graph is a function. This means for every single x value, there is only one corresponding y value. Second, the graph is continuous. You can draw it from end to end without ever lifting your pen from the page. There are no gaps, breaks, or jumps. Third, it is symmetrical about a vertical line called the axis of symmetry. This line, given by x equals negative b over 2a, divides the parabola into two identical mirror images. This symmetry is a hallmark of parabolas. Fourth, its domain is all real numbers. This means you can plug any number you want for x into the equation. So we write the domain as x is an element of R. Fifth, the range depends on the turning point. The range is the set of all possible y values. We write it as y is greater than or equal to the y-coordinate of the turning point. This turning point is either the lowest or the highest point on the graph. And finally, a parabola in this form does not have an inverse function. An inverse function would have to pass the horizontal line test, but a parabola's U-shape means it would fail. So we've seen the general form y equals ax squared plus bx plus c. But how do we actually sketch one? To draw an accurate parabola, we need to find 5 critical pieces of information. Let's list these 5 critical values we must find to sketch any parabola. First, we determine the shape. This is done by looking at the sign of the a coefficient in our equation. If a is positive, our parabola opens upwards and has a minimum turning point. If a is negative, it opens downwards and has a maximum turning point. So the sign of a tells us the overall direction. Second, we find the x-intercepts. These are the points where the parabola crosses the x-axis. At these points, the y value is 0. So to find them, we set y equals 0 in our equation y equals ax squared plus bx plus c, and then we solve the resulting quadratic equation for x. We can do this by factoring or using the quadratic formula. Third, we find the y-intercept. This is the point where the parabola crosses the y-axis. At this point, the x value is 0. To find it, we substitute x equals 0 into our equation. Notice that the a times 0 squared term and the b times 0 term both become 0, leaving us with y equals c, e, so the y-intercept is always at the point, 0, c. This is a very handy shortcut to remember. Fourth, we find the axis of symmetry. As we discussed, this is the vertical line that divides the parabola into 2 equal parts. Its equation is given by x equals negative b divided by 2a. This formula is absolutely essential. Fifth and finally, we find the turning point. This is the peak or valley of the parabola. Its x-coordinate is the same as the axis of symmetry, which is negative b over 2a. To find the y-coordinate, we simply substitute this x value into our original equation and solve for y. This gives us the full coordinates of the turning point, negative b over 2a and f of negative b over 2a. It's the most important point on the parabola. Now that we know the 5 critical values to find, let's turn this into a clear step-by-step process for sketching any parabola. Following these 6 steps will give you an accurate graph every time. We will now outline these steps one by one. Step 1. Determine the shape of the graph. This means figuring out if it has a maximum or a minimum turning point by checking the sign of the a coefficient. Step 2. Find the x-intercepts. Remember, we do this by setting y equal to 0 and solving the resulting quadratic equation for x. We're looking for where the graph crosses the x-axis. Step 3. Find the y-intercept. This is even simpler. We set x equal to 0 and solve for y. Remember, it will always be the value of c in the equation y equals x squared plus bx plus c. Step 4. Find the axis of symmetry. We use the all-important formula, x equals negative b over 2a. This vertical line tells us the center of the parabola. Step 5. Find the turning point. This is the vertex of the parabola. Its x-coordinate is the same as the axis of symmetry, and its y-coordinate is found by plugging that x value into the original equation. It's the most critical point for sketching. Step 6. Plot all the points you just found on a Cartesian plane, the axis of symmetry, the intercepts, and the turning point. Once these key points are accurately placed, draw a smooth, symmetrical curve through them to form your parabola. It's time to put these steps into action with an example. This will help you see the entire process flow together. Our example is as follows. Sketch the parabola described by the equation y equals x squared plus 3x minus 4, and then state 6 important features of the graph. To sketch this graph, we must find the critical values by following our 6 steps. First, let's identify our a, b, and c values from the equation. In y equals x squared plus 3x minus 4, the coefficient a is the number in front of x squared, which is 1. The coefficient b is the number in front of x, which is 3, and the constant c is negative 4. Knowing these 3 values is our starting point for everything that follows. Let's apply our 6 steps to our example. Y equals x squared plus 3x minus 4. Step 1. Determine the shape of the graph. We look at the value of a. Since a equals 1, which is greater than 0, the graph will have a minimum turning point. This means our parabola will be U-shaped. Step 2. Find the x-intercepts. We set y equal to 0, which gives us the quadratic equation x squared plus 3x minus 4 equals 0. Let's solve this by factoring. We need 2 numbers that multiply to negative 4 and add to 3. Those numbers are 4 and negative 1. So we can factor the equation into the form x plus 4 times x minus 1 equals 0. This means that either x plus 4 equals 0 or x minus 1 equals 0. Solving for x gives us x equals negative 4 or x equals 1. Therefore, our 2 x-intercepts are at the points negative 4, 0 and 1, 0. Step 3. Find the y-intercept. We set x equal to 0. Substituting 0 for x, we get y equals negative 4. So the parabola crosses the y-axis at the point 0, negative 4. We've found the shape and the intercepts. Let's continue with our example y equals x squared plus 3x minus 4. Step 4. Find the axis of symmetry. We use the formula x equals negative b over 2a. We substitute our values. Negative 3 divided by 2 times 1. This simplifies to x equals negative 3 over 2, or negative 1, 5. This is the equation of the vertical line that divides our parabola in half. Step 5. Find the turning point. The x-coordinate of the turning point is the same as the axis of symmetry, which is negative 3 over 2. Now we substitute this x value into our original equation to find the y-coordinate. Y equals negative 3 over 2, all squared, plus 3 times negative 3 over 2 minus 4. Simplifying, we get 9 over 4 minus 9 over 2 minus 4. To combine these, we find a common denominator, which is 4. This gives us 9 minus 18 minus 16 all over 4. This simplifies to negative 25 over 4. This value, negative 25 over 4, is the y-coordinate of our turning point. In mixed number form, this is negative 6 and 1/4. So our turning point is at the coordinates negative 3 over 2, comma negative 25 over 4. This is the lowest point on our parabola. We're on our final step for sketching our parabola. Y equals x squared plus 3x minus 4. Step 6. Plot all the critical points and sketch the graph. Let's recap what we found. We have x-intercepts at negative 4, 0, and 1, 0. Our y-intercept is at 0, -4. The axis of symmetry is the line x equals -1.5, and the turning point is at -1.5, -6.25. Let's plot these points on a Cartesian plane. First, the intercepts, -4, 0, 1, 0, and 0, -4. Next, let's draw our dashed axis of symmetry at x equals -1.5. And finally, we plot the turning point at the exact center of this line, -1.5, -6.25. Notice it lies exactly on the axis of symmetry. Now we draw a smooth U-shaped curve that passes through all of these points, respecting the axis of symmetry. And there you have it, the sketched graph of y equals x squared plus 3x minus 4. The memo also states that critical values can be found using differentiation. This is a powerful method you'll learn about in higher-level maths, specifically in Unit 5.6.2. For now, our algebraic method is perfect. Our example had a second part. State 6 important features of the graph of y equals x squared plus 3x minus 4. We can now do this by looking at our sketch and recalling the general features we discussed earlier. First, the graph is a function. For every x, there is exactly one y. Second, the graph is continuous. You can draw it in one go. Third, the graph is symmetrical, and we found the exact line of symmetry. X equals -3/2. Fourth, the domain is all real numbers. You can input any x value into the equation. Fifth, the range. Since our parabola opens upwards from a minimum turning point, the y values must be greater than or equal to the y-coordinate of that turning point. So the range is y is greater than or equal to -25/4. And sixth, this graph in its entirety has no inverse function. As we mentioned before, it fails the horizontal line test. Let's quickly compare our solution with the provided memo. Looking at the steps, the shape, x-intercepts, y-intercept, axis of symmetry, and turning point calculations are all identical. The final sketch is also a perfect match. Both our graph and the memos show the correct intercepts, axis of symmetry, and the exact turning point. Finally, the 6 features we stated for the graph are exactly the same as the ones listed in the memo. This confirms that our step-by-step method is accurate and reliable. We have successfully sketched the parabola and identified its key features. Let's recap what we've accomplished today. We started by understanding the general form of a parabola, y equals ax squared plus bx plus c, and its fundamental features like continuity and symmetry. We then learned a powerful 6-step process for sketching any parabola, finding the shape, x-intercepts, y-intercept, axis of symmetry, and turning point, and then plotting them. Finally, we walked through a complete example, from calculating the critical values to sketching the graph and stating its features, confirming our work against a memo. You are now equipped with the tools to sketch and analyze parabolas with confidence. The key is practice and remembering those 5 critical values. If this tutorial was helpful, please subscribe for more tutorials from Math Zone African Motives. Thank you for watching.